Hello, my name is Rebecca Sanders. I'm an assistant professor of chemistry here at North Central College, and I will be joined in the second half of this presentation by Professor Paul Bloom, who's an associate professor of physics. Both Paul and I are faculty members in the environmental studies program here at North Central, and we both regularly teach a variety of courses, some of which highlight things happening to our environment and the science behind them. This semester, both Paul and I will be teaching sections of the science of climate change. So when the COVID pandemic of this past year arose, it caused us to ask the question, how has the pandemic altered human behavior and ultimately changed the environment for the better and for the worse? So the goal for today is to first give a background about the Earth and how humans have altered our environment. From there, we're going to talk about some trends that we've seen once the pandemic arose, first in China and then throughout the world. What were some of the positives and negatives that came from the big scale changes in human behavior in a very short amount of time? And that will lead us to ask some questions about what does the future potentially hold and what are things that we can do to help. So we have to start with the big picture. The Earth is over 4 billion years old, and it's really a beautiful system that has a delicate balance of lots of natural cycles. These cycles have evolved over time, and they've evolved slowly over time. One of the cycles that's going to be really important to our conversation today is the carbon cycle. Now, carbon comes in lots of different forms. You find it in gases in our atmosphere, like carbon dioxide and methane. You find it as one of the key components to plants and animals. You find dissolved forms of carbon present in the ocean, and then you find lots of carbon incorporated into soil and rocks. What's amazing about the Earth is how the Earth has delicately balanced that carbon cycle. For example, there's some amount of carbon stored on Earth and some amount of carbon stored in the atmosphere. We call these pools of carbon. There's exchanges of these pools where some carbon is released into the atmosphere by things like respiration, us breathing, by the growth of plants where you put CO2 in the atmosphere. But that is nicely balanced. You'll notice these numbers are very similar. That is nicely balanced by the uptake of carbon from the atmosphere by things like soils and plants. Similarly, we have that pool of carbon in the atmosphere balanced with the pool of carbon in our oceans. Some amount of CO2 is released into the atmosphere, and that's delicately balanced by the amount of CO2 that is absorbed by the oceans. Over time, the carbon cycle and many other natural cycles have evolved to find these delicate balances where the amount going into and out of the atmosphere is relatively similar. And therefore, the net amount of carbon you would find in the atmosphere is relatively constant and shouldn't change very quickly over time. Of course, we know that humans evolved on the planet, and they've really only been around for about 200,000 years. So we're talking about much less than 1% of the Earth's history have humans been on the planet. When humans are on the planet, all kinds of things have changed. It's really important for us to understand not only when humans were first found on Earth, but how the population has changed over time. Over 10,000 years ago, there were just about 4 million people on the planet. And at that time, that's about the time where hunting and gathering was happening. And over time, as the human population grew for the past 3,000 to 6,000 years ago, there was larger scale changes starting to be made to the Earth as rather than hunting and gathering was taking place, larger scale farming and raising of livestock came into being. As humans evolved and started to shift their patterns of gathering food, that started to alter our land. What happened more recently is the human population has dramatically exploded in the past few centuries. One of the primary drivers of that explosion in the human population is the Industrial Revolution. We found a way to harness the power of fossil fuels, starting with coal and then working our way to natural gas and oil. And by powering the earth, we were able to do things on a much larger scale that supported the growth of the human population. For example, now we could farm on larger systems, we could travel to further distances, and we had better health care. All of these things helped it for the population to grow. So much so that by this time last year, the population on Earth was 7.7 billion people. Projections through the end of the century increased the population on Earth by a couple more billion people. When we have all of these people living on the earth, utilizing some of the benefits that come along from changing the land and burning of fossil fuels, we have now upset that delicate balance of the carbon cycle. There are changes to carbon going into and out of the atmosphere due to changes in the way our land is used. But more importantly, because of industrial processes, because of the combustion of fossil fuels, we are taking carbon that has been buried in the form of fossils and of dead plants from hundreds of millions of years ago. We're burning that and we're putting that carbon that was sequestered by the earth for long amounts of time back into the atmosphere. By upsetting the delicate balance of the carbon cycle, we are changing our atmosphere and we're changing our environment. One of the easy ways to visualize that upset of the delicate balance is to think about carbon emissions and the total amount of emissions like carbon dioxide in the atmosphere as a bathtub. So you can imagine that if you have a bathtub being filled with a faucet, where the faucet is pouring water into the bathtub faster than the drain can remove the water, the net effect would be a rise in the amount of water in the bathtub itself. So that's exactly what's happening. As we're changing our land and as we're burning fossil fuels, we're putting carbon dioxide and other emissions into the atmosphere faster than they can be drained away. The net result of that is an increase in the amount of carbon dioxide in the atmosphere. Current projections of carbon dioxide in the atmosphere are over 400 parts per million. Now, parts per million means that in the atmosphere, only 400 out of a million parts of the atmosphere are made out of carbon dioxide. That's a small fraction of the atmosphere, but that small fraction of the atmosphere is a big player when it comes to the greenhouse effect. We naturally have some greenhouse gases in our atmosphere. Greenhouse gases are things like water, carbon dioxide, nitrous oxide, methane. If there were no greenhouse gases in our atmosphere would be about 30 degrees Celsius colder than it is today, and life would cease to exist. The greenhouse effect is not a bad thing. It keeps the Earth at a reasonable temperature for us to exist. What is troubling is the fact that we've just seen in the previous slide an increase in CO2 and other greenhouse gases being added to the atmosphere more quickly than they can be removed. I like to think about the greenhouse effect as a blanket. Our natural greenhouse effect is a nice, cozy, comfortable blanket. But what we're doing by adding more greenhouse gases into the atmosphere is we're making a thicker blanket and we're getting too hot. The Earth is retaining more heat than it was retaining before, and the net result is the Earth is heating up. We've got data going back about 150 years that keeps track of what the temperature has looked like on the Earth. So on the y-axis, we're looking at something called temperature anomaly, which is basically averaging out what the temperature was from about 1960 to about 1990. And what we see here is a change in temperature compared to that about 30-year average. The general trend, yes, there's some ups and some downs, but the general trend is an increase in temperature over time. Why is that problematic? We see that that increase in temperature is occurring, and it might beg you to ask the question, is that normal? The answer is yes. To some extent, it's normal for the Earth to change temperature over time. We have delicate balances in things like the carbon cycle that have evolved over time. But I'm going to show you a cool website on the next slide that depicts to us in a more dramatic fashion why this change in temperature on the time scale that we're seeing it is a cause for concern. So what I've got here is I've got a video of a website from what's called XKCD. This is a really great cartoon that's going to show us how temperature has changed over time. So I'm going to let this guy load. And what I want to point out is that we start where we've got cooler temperatures and warmer temperatures. In the middle is temperature compared to the later part of the 1900s. We start at about 20,000 years ago, and you'll notice the general idea is that the temperature is really cool, about 4 degrees Celsius cooler than it currently is. And what I want you to do is I want you to watch this little dotted line as it pops up. And this dotted line is going to show you what's happening with respect to temperature over time. Remember, we're starting about 20,000 years in the past, and we're working our way to present day. So as we work our way through this, we'll see that we've got temperature staying cool. We start to see murals on the wall in France, humans arriving in North America. We start to see glaciers retreating, ice sheets from Chicago go away, humans settling the Sahara, excuse me. We're warming up, again, gradual changes, getting a little bit warmer than it was at the end of the last decade. We see settling happening in China. We see humans developing copper metalwork, gold metalworking. The Earth cools down a little bit due to some normal cycles. The wheel is invented. We're at about 3000 BC at this point. Stonehenge is complete. We start to see the evolution of iron smelting. We work our way to the time of Jesus and the Roman Empire. We start to see all kinds of things happening. And then hopefully what you're noticing, the most striking piece of information here is all of a sudden, those very gradual changes we observed over time jump up immediately. That is where we have a major cause for concern. We see this change in temperature that is not normal. Forgive the YouTube slides, we'll go on to the next figure. And so what's really striking is not the fact that the temperature is changing, but what's striking is the fact that the temperature is changing so quickly. In the Earth's history, there's lots of paleoproxy data that we can use to reconstruct the climate history of the Earth. And while we've seen times where the Earth is much warmer and much cooler than it currently is, we have not seen huge changes in temperature like what we're currently seeing. The reason for that is, and there's lots of data we could talk about to get to that point, but the reason for that is primarily human activities that are putting things like carbon dioxide into the atmosphere. The effect with which humans have on the atmosphere is not equal across the planet. Generally speaking, the more wealthy countries, the ones with higher GDPs per capita, generally are using more than their fair share of fuels. So for example, the US has a higher GDP and is emitting much more CO2 in the atmosphere than, say, China or India. So not only do we have to factor in how many people are on the planet, but we have to factor in the wealth of the people on the planet recognizing that the wealthier people are contributing more to that water being added to the bathtub, causing an increase in our greenhouse effect. I've shown you how increases in CO2 and lead to increases in temperature, but there are several other things that humans have done to alter the planet. For example, land use changes have severely altered the planet. We have changed where you find forest, for example. In this particular image, anything that's colored was a forest or woodland region. The current intact forests are the ones in the darker green. Anything in a lighter green is a fragmented forest. Anything that is in yellow is a degraded forest, and anything that is in a beige color is a deforested area. What I hope you see from this image is the idea that there has been a large portion of our land where we've taken down trees to utilize the trees, to grow livestock, to develop lands for buildings, for example. And we've altered our carbon cycle by changing the amount of forests that you would find on the planet. So as we've altered the land, we have developed the land, we've grown and have developments, large cities. We need to feed this enormous population on the planet, so we have large scale farming for crops and for livestock. We have to energize the planet. We drill for oil, we mine for coal. We use a lot of stuff. When we use a lot of stuff, inevitably we have pollution in the form of pollution in the water, on land, pollution in the air. What does the future hold? Unfortunately, it's not good. The Intergovernmental Panel on Climate Change is a group of scientists worldwide that come together and release reports every, say, 5 to 7 years. And they take the best science there is out there to tell us where we currently are and to make some projections about the future. Projections are done in a variety of scenarios, where there are scenarios that are sort of best case scenario and closer to worst case scenario. And these projections generally show that we could have temperature increases by the end of the century of 3 to 5 degrees Celsius warmer than where they were at the beginning of the century. That's if we don't change our habits, we just live business as usual. When those temperatures increase, they increase disproportionately on the Earth to places like the poles, where you find lots of ice that will melt. When it melts, we're going to worry about changes to our water cycle. We're going to worry about changes to sea level and everything that comes along with that. There will be changes to our water cycle in terms of precipitation. Some areas will become drier, some areas will become wetter. We'll get extremes on both cases, where that means there will be an increased likelihood of both more droughts and more flooding. As melting occurs, as thermal expansion expands the water volume in the oceans, we can expect to see sea level rise from about 0.5 meter to 1 meter by the end of the century. In addition to that, as we put more CO2 into the atmosphere, some of that gets absorbed by the oceans. When carbon dioxide is absorbed by the oceans, what happens is that acidifies the ocean. It makes it a little bit more acidic. Why is that problematic? When oceans are more acidic, then what will happen is it makes it more difficult for many of the organisms that live in the ocean to grow. That has huge impacts on the food cycle. So this is a really text-heavy slide, but I want you to recognize that there are major impacts that come from climate change, pollution, all of these impacts that humans are having on the planet. Not only are there large global impacts, but there are impacts that will happen at the regional and local level. The Intergovernmental Panel on Climate Change says that these impacts are already being observed on our climate system, and they will only worsen as temperatures increase. What that means is that ecosystems are going to have to shift or degrade. We're going to run into problems with fresh water supplies, and those are either going to have to shift or degrade as well. So for example, in the western portion of the US that's already kind of water starved, when there's less snow on the mountains, there's less snow melt, and there's less fresh water available to all of the people that live in places like Las Vegas that are already deserts. When we stress these ecosystems, it puts stress on food production, it puts stress on infrastructure. As ecosystem shifts, that means that disease carried by different organisms will shift and expand as well. Every aspect of the human and natural world will be impacted by climate change. Some of these impacts can be adapted to. For example, if it's hot outside, you can turn your air conditioner on. What's the problem with that? The problem with that is that you're using energy to run that air conditioner. If that energy is coming from a fossil fuel, you're just propagating the problem. It's more challenging for the nations with fewer resources to adapt to some of these challenges. And by the end of the century, if we keep business as usual, even the wealthiest nations are going to be challenged by the effects of climate change. When Professor Bloom and I both teach the science of climate change, we find ourselves commonly at this point in the semester when we talk about the impacts of climate change, talking about the idea of what if something could happen to change things tomorrow. It's really hard to imagine the idea of dramatic, large-scale shifts in human behavior overnight. But we didn't expect 2020. And what's amazing about this year is we now have a case study and what shows to show what happens when humans suddenly change their behaviors on a large scale. So now Dr. Bloom's going to take over and show some data that suggests what happens when humans actually do change their behaviors.
Thank you, Dr. Sanders. Indeed, the business as usual future that you've described is a scary one. The ecological and damage and the suffering that will be inflicted on our fellow human beings is beyond comprehension. But we know that if we reduce our greenhouse gas emissions, we can radically improve the future outlook. The best science tells us that we must keep total warming relative to pre-industrial levels at about 2 degrees Celsius if we want a future that we can successfully adapt to. And to do this, we will have to keep total cumulative emissions of carbon dioxide below well understood levels. The area under these mitigation curves tells you the total amount of carbon dioxide we put into the atmosphere. But they also tell you an important story, which is that the longer we wait to start reducing our emissions, the faster we will eventually have to make those changes. And unfortunately, we've already waited far too long. The good news is that making these changes is no longer a scientific or technological problem. Instead, it is a problem of politics and ultimately of the will to change. And it's a hard question. How do you convince an entire civilization to change so much so quickly? This has been a baffling question for those of us who study the climate problem, and it's one that we faced together in 2020 as we encountered the COVID pandemic. The video that I'm showing you shows how the pandemic played out, first starting in China, then spreading to other countries, and as we are all too familiar with the story, once the spread of the COVID-19 virus went beyond the point where quarantine and contact tracing could stop it, the only way to prevent catastrophic levels of infection and mortality was simply to shut it all down. And faced with imminent illness and death, people made huge changes in behavior. They did so begrudgingly, to be sure, but they did it. All but essential workers stayed home, people traveled significantly less and worked remotely, and these changes had the desired effect. They stopped the exponential growth of the virus. But they also serve as a demonstration of what is possible in the face of a recognized threat. We are capable of making huge changes to our behaviors in a very short period of time. So the graphs that follow show some of the things that we've measured that have happened because of the lockdown. The first thing is we changed our use of energy. You can see first in China and then in other countries as they locked down in following weeks, that total energy usage plummeted, primarily due to reductions in transportation, but also in reductions of economic activity, manufacturing, and this happened very quickly. Here you can see the electricity demands, and again, in each and every case, once the lockdown begins, reductions took place, 10, 20, 30% reductions in the amount of electrical energy used. To get a sense of the impact on carbon dioxide emissions, you can see the plot on the left shows the annual, or rather the daily emissions graphed since 1970. And you can see they've been going up and up and up. In the last few years, not quite as quickly, but still heading up. And then suddenly, they plummet by nearly 20%. The graph on the right shows the details of that decrease, and it's entirely due to the economic slowdown associated with COVID and the reaction to the pandemic. This set of graphs breaks down how CO2 emissions changed by economic sector. There was a decrease in emissions due to reduced power generation, a somewhat larger decrease due to reduced industrial output. Public consumption went down because people were not going out and doing things. You can see that residential consumption, or rather emissions due to residential consumption of energy, ticked up slightly, and that makes sense because more people were at home. But the really striking changes here are due to reductions in transportation, both surface transport and aviation. And there, CO2 emissions plummeted. And it's because not only do we use less energy in those areas, but all the energy that we do use in those areas comes from fossil fuels. Right? The reason residential energy CO2 emissions didn't kick up very much was because a lot of the electricity that we use in residential settings is already coming from renewables. And it wasn't just carbon dioxide. The shutdown due to the pandemic resulted in all kinds of pollution reductions. The plots on the left show a year-on change of nitrous oxide emissions, and you can see that throughout the United States, nitrous oxide emission levels went down substantially, quite a bit, especially in some of the major metropolitan areas. Of course, when there's less air pollution, it passes the eye test, and you can see the graphic showing the difference in the air quality in New Delhi, or famously in the canals of Venice, that air quality and water quality improved. But it's not all good news. As part of our response to the pandemic, some things happened that actually were bad news for the environment. The EPA relaxed a lot of rules for polluters as part of making everything easier to cope with and presumably trying not to crash the economy entirely. There are increasing numbers of face masks and gloves being found in the ocean now, so discarded PPE equipment. plastic bag rollbacks, plastic bag bans got rolled back because plastic bags are less likely to transmit the virus than our cloth. COVID has also impacted the rollout of renewable energy resources, both in terms of wind power, solar power, and that slowdown has affected jobs that are associated with that sector of the economy. So there's a fair amount of bad news. And perhaps the biggest piece of bad news in all of this is that even though emissions went down, as things start to return to normal, we hope things are starting to return to normal, at least they are in a lot of the world, fossil fuel use goes back up. We return to business as usual. And as a result, you can see in 2020, coal consumption in China was depressed for a while, especially right after the Lunar New Year when their lockdown took place. But then it's creeping back up. And so even though we changed, we cannot seem to sustain those changes. Here's another example, air pollution levels in China. And you can see before the lockdown, very significant pollution. During the lockdown, pollution declined substantially. And then after their lockdown eased, pollution levels start coming back up. So what does this all mean? It's an enormous benefit to see that there is noticeably cleaner air and water, a visible sign of reduced pollution. That's a good thing, right? There's a lesson. It tells you if you stop polluting the world cleans itself up. The problem is carbon dioxide isn't quite a pollutant in that same way. We can't, of course, see carbon dioxide or other greenhouse gases, and there was certainly a reduction in those emissions, but then those levels are going to pop back up as our energy consumption returns to normal. The bigger problem is that carbon dioxide is also not like a regular pollutant in that once you emit it to the atmosphere, it stays there essentially forever unless you take it out. So unlike regular pollution that filters out of the air or out of the water, when we put carbon dioxide into the atmosphere, there it stays. So what does this all mean? The problem is that the overall reduction in greenhouse gas emissions that we saw during the meat of the lockdown was just a drop in the bucket. Right? You can see in the graph on the left that, yes, emissions went down noticeably and quickly, but even though they went down a lot, they only went down maybe to levels that we saw in the early 2000s. And we need to get those emissions down a lot lower. So, yes, there was a reduction, but the reduction didn't last for very long, and emissions are already on their way back up. And as we hope the pandemic continues to abate and the economy recovers, we will return to business as usual, which means our emission levels will go right back to where they were. Now, there is good news in this, in that we showed that it is possible to make rapid and large reductions in transportation sector emissions. And that's crucial because it turns out to be one of the hardest problems to solve from a technical standpoint if we want to get our greenhouse gas emissions down eventually to zero. So we see that this is possible. Right? If there's a will to change and there is a means to change, we still need a plan. And that's the job of policy. Policy lays out a pathway to decarbonization and provides economic incentives to hasten the transformation. The most important piece of any policy on pollution, and especially on climate change, is putting a price on carbon. And there are many ways to do this. One of the least regressive is a plan called fee and dividend, but the point is that somehow You have to make the real price of carbon emissions visible to the economy. Transportation is by far the most challenging sector to plan for decarbonization, but our experience in the pandemic suggests that there is a bridging strategy, a short-term way to really knock down those emissions very quickly. We have to travel less. We have to stay home and work remotely. It's not ideal, but that's the kind of sacrifice that we're talking about in order to get this problem under control. And we can do things like that. Individual action, business action, those are important. Those are big players. But to make this really work on a national and on a global scale, governments must lead the way. So where are we? I think it's not hyperbole to say that protecting our environment is the singular challenge facing humanity in this century. If we fail to do so, all of our progress, all of our great progress over the centuries is going to be rendered moot. Failing to protect our environment will make everything else that we want to do more difficult. And the greatest challenge in preventing disastrous climate change right now is a lack of will to make the needed changes to how we live our lives. The COVID-19 pandemic has shown us that people can make rapid, radical changes in how they live if they believe there is a reason to do so. And that's a big if, because we have also seen, there's evidence all around us, what happens when people choose to trust political spin instead of the science, right? How much noise has there been over something as simple as wearing a mask to protect the people around you? The science has to be listened to, and it has to factor into our choices. Our civilization right now is choosing its future now. What we do now matters. So what can you do? Well, as a consumer, you need to be aware of your carbon footprint. The things that you do, the things that you buy, the activities you engage in, everything comes not just with a dollar price, but with a carbon price. So just like you would often choose to make the most economical choice, opt for less carbon intensive choices when they're available. And by the way, make sure that part of that is your diet. The things you eat have a lot to do with the amount of carbon dioxide we put into the atmosphere. And one of the most important things about this is that energy efficiency not only saves you money, it cuts down on our emissions. And so it's a no-lose situation. What about as a citizen? You must demand, we must all demand, that government take the climate crisis seriously. And in general, take the protection of our environment seriously. It's something that's really gotten away from us and is too important to let go. We must demand that government take a science-based approach to dealing with the climate crisis and frankly with everything else. Believe what you want to believe, but when it comes to dealing with the real world, you have to trust science. It's the best way to figure out how to live and to live safely. Lobby your local, state, and federal representatives. Tell the people who represent you in government what you want. One of the ways you can do that is join a local organization such as Citizens Climate Lobby, and there are many others. And of course, the most important thing is vote. If somebody isn't going to use science to protect our world, I wonder if they are trustworthy to receive your vote. So in conclusion, as with COVID-19, there is no single solution to protecting our environment. But while there is no silver bullet, there is a silver shotgun. There are many, many things that we can do to help choose a better future. And the question is not what will you do, but which of the many things will you do? But you must choose, because the time for acting is now. As an individual, even as a generation, we do not have to complete the work of solving this problem, but we cannot ignore it any longer. So thank you all, and now we'll have a Q&A session.